Hey, ladies and gentlemen, this is Chapter 6. If you made it this far, you survived Chapter 5. Chapter 5 is a big chapter, guys, so don't be afraid to go back and look at that stuff throughout the year. But let's start talking about what's in Chapter 6. The first bell ringer I have here for you is scientific notation. Remember, scientific notation puts the number between 1 and 10, basically. So this is 4.23. I would do 10 times in a second because I moved it 2 decimal places. This will be 2.0 times 10. I'm going to count out how many places. That would be 6. I moved it. And number 3. This will be 2.0 again times 10. Let's see how I can move it. 1, 2, 3, 4, 5, 6. And since it was backwards, I'm going to go negative 6. Okay? And then this is 9 times 10 to the second. Okay? There's your scientific notation. Play around with that, ask questions, fire away. Let's move down here to your rules. You can see your goals and your EQ, which would be how do we use properties of exponents to evaluate and simplify expressions involving power, and how do you use that to solve real life equations or problems. That's why nobody likes math, right? Because we're full of problems all the time. But here are your properties. When you multiply the product of powers property, when the bases are the same, you would add the exponents. When you do a power to a power, you would multiply those together. So m times n, whatever that is, that's your exponent for a. ab to the m, distributed into both exponents, which would be understood to be 1 here, so 1 times m is f, and 1 times m is n. Right? And negative exponent property does nothing but put this in the denominator, so it'll be a to the m in the bottom. Not actually the top. That gets rid of the negative in the exponent. Don't forget that one. That one will come back to haunt you in calc. Zero exponent property. Anything to the 0 power is number 1 in our hearts. A cannot be 0, then it wouldn't be applicable, if that's a word. Quotient of powers property. All you would do is subtract the exponents. Think about it. When you multiply, you add them. When you divide, we'll subtract. Again, distribute the m into both exponents, so it'll be a to the m and b to the m. And those are all your rules. All we have to do now is apply them to real problems. If you're like me, that's great. Don't tell me about it. Show me how to do it. That's just how I want it. But let's give it a shot. The bases are the same, so I can rewrite 5. 3 plus 6 is what I'm going to do. So that's 5 to the 9th. An easy way to think of this, the rule, this is 5 times 5 times 5. And then you have this asterisk times. And then you have 6 5s over here. So if you think about it, how many 5s are we multiplying together? There's 9 of them there. So 5 to the 9th. This is how we arrive there. So when we do this one, this is x to the 4 plus 3 plus 2. So this is x to the 9th as well. Over here with 2, think of this as a 1. So this is negative 2 to the 6th. Okay? And that would be it for that guy. You would be finished. 3 to the 6th. Do 3 times 2. Okay? Power to a power you would multiply. And over here, this would be negative 3 to the 10th power. 2 times 5 is the 10th. Okay? It doesn't say evaluate, just express as a single power of the base. So you're leaving the base as is, you're writing the new exponent. So that's why I'm stopping here. I could actually do negative 2 to the 6th. I could actually type in the calculator negative 3 to the 10th. But it's not telling me to evaluate. This is just rewrite the expression. All right? Simplify the quotient. Now, when you divide, you subtract exponents. This would be 5 minus 3. So this is negative 3 squared. I should keep it in place, which is 9. Over here in 2, this will be x to the 9th minus 13. So this is x to the negative 4th, which would be 1 over x to the 4th. The shortcut I usually do when I look at this is I see I have an x on top and bottom, so I rewrite x on bottom, and I do 13 minus 9 is 4. So like if you were to do that here, this is 2 to the 5th minus 5. So that's 2 to the 0, which is 1. Or you can just see it here that anything divided by itself is 1. Over here, this is 5 to the third, this is 4 to the third, 5 to the third is 125, 4 to the third is 16 times 4 is 16. Those will not be able to be reduced. Over here in 5, I'm just going to take care of the negative exponent. When I do that, I flip my fraction inside. I am now going to square my 5 and square my 3. So 25 ninths. Same idea here. I'm going to flip this, x over 1 to the 4th. Get rid of that negative exponent by flipping it, and then this is just x to the 4th. So there are your first 6 problems. Okay, let's take a look at 7, 8, 9. So this is going to be negative x to the 5th over 2 to the 5th. Now, negative times a negative times a negative times a negative times a negative is still going to be negative, so you don't really have to keep it in parentheses. You can literally write it like that. 2 to the 5th, let's see, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. Okay, so 2 to the 5th is 32, can't reduce. Over here in 8, this is x to the 3rd over x to the 10th. So I basically am going to say 1 over x to the 7th. 10 minus 3 is 7. X is bigger on bottom. Okay, that's the shortcut now. I'm going to stop writing this as x to the 3rd minus 10, and then x to the negative 7th, and then just move it to the bottom. I'm just going to go right to this. Okay? On top, x to the 11th over x to the 8th. X is clearly larger on top, so it stays on top. 11 minus 8 is 3. So x to the 3rd. All right. Let's see. Next set here. Practice. To simplify the expression, use only positive exponents. We can do that. We can do that all day. So let's get to work. First I'm going to do is get rid of the negative exponent here to make life a little bit easier for myself. So that y to the 3rd comes on top. The x has a positive 1 exponent, so leave it. And now I'm going to distribute my power in. So this is x squared, y to the 6th. And you can stop there. They're all positive exponents. We're good to go. I'm going to choose to distribute the 3 in here this time. This is 3 to the 3rd, b to the negative 6th times b to the 8th. 3 to the 3rd, let's see, 3 times 3 times 3 is 27. And this is b to the 2nd. Negative 6 plus 8, add these exponents. Coming over to 12. Okay, I have 20, x to the 4th, y to the 5th. What I'm doing here is adding my exponents. 3 plus 1 is 4, 3 plus 2 is 5. 2 times 2 is 4. This is x to the 1st, y squared. I'm going to reduce now. 20 over 4 is 5 over 1. X to the 4th, x to the 1st, x is bigger on top. 4 minus 1 is 3. Y to the 5th, y squared, y is larger on top. 5 minus 2 is 3. So 5x cubed, y cubed, that's it. Okay. 13. I'm going to take care of this negative exponent, and I'm going to reduce this fraction. So x over x squared, x is going to be on bottom. 2 minus 1 is 1. Y to the negative 2nd puts y to the 2nd on bottom. I'm going to flip this. This is y over x to the 4th. And raising it to the first power won't change anything, so I'm just going to get rid of that negative 1 by flipping this fraction. Going across, I have 1y over x to the 5th y squared. I'm going to reduce my y's. So 2 minus 1 is y to the 1. And that's it. I think it seems so simple, right? All right, 14. I'm going to get rid of my negative exponents here. So I have x to the 3rd, y to the 1st all over 1. This negative is going to flip this. And then I'm going to multiply every exponent by 3. So 2 times 3 is 6, and x is on the bottom. Okay? I'm going to multiply across. X to the third, y to the fourth, all over x to the sixth. So this is y to the fourth, x to the third. 6 minus 3 is 3. Y to the fourth gets rewritten. Okay? And here we go again. We can finish this guy up. Oh, there's actually another page. That's exciting. All right, given the expression, yada, 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 which value of x makes the expression equal to a hat? So what I'm going to do is I'm going to show you how to rewrite radicals in fraction form. This is, I'm sorry, 1/5. So radicals are fractions in the exponent. We want to know which value of x makes the expression equal to a half. Okay, so what we're going to do here is we're basically going to evaluate the left side, and then we'll start talking about it. So we're going to multiply negative 8x times 1/8. That's going to give me negative 1x. Plus x, this is going to give me negative 1x when I multiply 1/5 times negative 5. This is equal to 1 over 2. I am going to add these. These are like terms. So this is x, 2x to the negative x equals a half. And I'm going to multiply this by 1/4. Oh, I'm sorry, I'm already doing math in my head. I'm going to multiply both sides by a half to isolate my x's. So this would be x to the negative x equals 1 over 4. Okay? And what I'm going to do is I'm going to get rid of this negative exponent by putting it in the denominator. And I'm going to rewrite 1/4 as 1 over 2 squared. As 4 is 2 squared. So you can clearly see x is 2. All right? Voila. Life was good. Moving along. That was probably a challenging one, and it should be. That's why it's there. Okay. How about 16? What is the value of n? Well, I don't know. Let's check it out. X to the 10n. I'm going to have x to the 5th times x to the negative 5n. Power to a power, I'm going to multiply those. I'm basically doing the order of operations slow instead. I'm now going to multiply this. So I'm going to have x to the 5 minus 5n. Remember, you add exponents when you multiply, so 5 plus negative 5n is 5 minus 5n. Okay. I now have multiplication here still. Apply some space. I'm going to multiply these together. So that means I'm adding my exponents. So this is x. 10n plus negative 5n is 5n. Still have plus 5 equals x to the negative 10. Now my bases are the same, so I don't have to keep looking at them. I'm going to focus now my attention on the tops, which would be 5n plus 5 being equal to negative 10. And once you get that set up, we can now solve for n and get a negative 3, which would make those equal. So when I put negative 3 in here, I'm going to get x to the negative 10 equals x to the negative 10. And no matter what x is, that's always going to be true. So you know that negative 3 is correct for n. All right, extra practice. I'm going to have to hit the fast forward button here, so that way I don't run out of time in this video. So I'm going to pause it, and then I'll have the workout for you. All right, so here are your first two of the extra practice. What I did is I took 3x to the 7th, and I actually distributed the 7 in, so I get 3 to the 7th, x to the 7th, and I'm comparing it to 3 to the 1st and x to the 7th. So the real difference is this is 3 to the 7th and this is 3 to the 1st, which obviously are the same. If you do this literally, what is the difference between them? The difference is 2,184x to the 7th, because we would expand this. We get 2,187x to the 7th minus 3 of those x to the 7th. So you have 2,184x to the 7th left. Yeah, the difference is 3 to the 7th, 3 to the 1st. Putting these in order, this shouldn't be too bad. 2 to the 3rd is 8, 3 squared is 9, 4 to the 0 is 1, 0 to the 4th is 0. So smallest to largest, 0 to 4th, 4 to the 0, 2 cubed, and then 3 squared. All right? I'm going to pause this again, and I'm going to go ahead and knock out 3 for you. All right, guys, here's 3 and 4. In 3, you can clearly see the answer for both. And you can see the sum is 1,295,000.